Hi students, this is a lecture session on Module 6 of Object-Oriented Programming. This lecture session is as part of RSET Online. I'm SEEMA SAFAR, Assistant Professor, Rajagiri School of Engineering and Technology. The topics that will be covered in this session includes Android manifest file and various permissions that is possible in Android manifest file, and then layouts in Android. Let's begin the session. Android manifest file. Android manifest file is an XML file which contains information of your package, including components of the application such as activities, services, broadcast receivers, content providers, etc. Now, every Android application will be having an Android manifest file, and it is located inside the root directory. Now let's discuss about the elements inside Android manifest file. A manifest file starts with a manifest element, and this is called as the root element of Android manifest file. It has a package attribute, as you can see here. The package attribute which describes the package name of the activity class. Then we have a uses SDK element, which will be discussed in the coming slide. Then we have an application element, which is a sub-element of manifest. It includes the namespace declaration, which contains several sub-elements that declares the application component such as an activity. Now, as you can see here, there are different attributes that has been defined here. Icon, label, and themes are the commonly used attributes in this element application. Icon represents the icon for all Android application components. Android label works as default label for all Android application components. Android theme represents a common theme for all Android applications. It represents a common theme for all Android activities. Then we have the activity tag or the activity element, which is the sub-element of application. Now, this represents one activity that must be defined in Android manifest file. So, activity comes as a sub-element of application. Now, it contains many attributes like name, labels. Now, name is an attribute which explains, which represents the name of the activity of class. And label represents a label that is displayed on the screen. Now, another sub-element which you can see inside activity is intent filters, which you have already studied. Now, this is the beginning of intent filter tag, and this one shows the end of the intent filter tag. Usually, intent filters have category and an action tag. Now, action tag defines which additional action is to be added to intent filters. So, at least one action element will be there for every intent filters. Then we have a category tag which adds a category name to an intent filter. Now let's discuss about uses permission in manifest file. Uses permissions are contained in manifest element. Now, when do we write a uses permission in manifest element? When we are requesting for a permission that the application must be granted in order for it to operate correctly. Normally, permissions are granted by the users when the application is installed, not while it is running. That is what you should understand. The syntax of user's permission looks like this. Here you can see an attribute Android name. Now this attribute specifies the name of the permission that you are requesting for. So what are the types of permission that you can request? Now it can be a system permission, like you're trying to access a camera in smartphone for your application. Then you need to specify it as a system permission. If you are requesting for a permission defined by the application with the permission element, you have to mention it likewise. Or you can request for a permission which is defined by another application. Uses SDK in Android. Uses SDK are used to express an application's compatibility with one or more versions of the Android platform by means of an API level integer. An API level integer is a value that uniquely identifies the framework API offered by a version of the Android platform. Okay. So the API level expressed by an application will be compared to the API level of a given Android system. Now, the syntax of uses SDK in manifest file looks like this, where you can see three attributes. One is min SDK version, which is assigned to an integer value. Then target SDK version, which is again assigned to another integer value, and max SDK version. These are the three attributes which is included inside uses SDK. Min SDK is an integer which designates the minimum API level which is required for the application to run. Now, Android systems will prevent the user from installing the application if the system's API level is lower than the value which is specified in this attribute. Okay. Now, moving on to target SDK version. Again, this is an integer which is designating the API level that the application targets. If it is not set, then a default value will be given to it, and that is usually minimum SDK version value which is assigned to it. Then we have a maximum SDK version, which is an integer designating the maximum API level on which the application is designed to run. Now let's discuss about layouts in Android. A layout defines the structure for a user interface in your app. Now, how do you write or how do you build a layout? A layout, all the elements of layouts are built using a hierarchy of views and view group. You are aware of what a view is. Views, recall what you have studied about view. View usually draws something the user can see and interact with, right? So you have studied about edit text view, button view, image view. Whereas a view group is a container, invisible container. It's an invisible container which defines the layered structure for view and other view group objects. That is, suppose that you have a button and a text view in your app. View group will be defining a layout structure for these view elements. Understood? Now, how can you declare a layout in Android? A layout can be declared in two ways. One method is by declaring the user interface elements in XML file. Hope you remember that you have an XML file when you're trying to build your Android app. When you're trying to build your Android app, you'll be having an XML file and a Java source file, right? Now, you can declare the user interface elements in XML file, which means Android provides an XML vocabulary which corresponds to the view classes and subclasses. Either you can use that, or you can use Android Studio layout editor to build your XML layout. Normally it's a drag and drop interface. Either you can declare your layout in that way, or you can instantiate layout elements at runtime, which means your app can create view and view group objects programmatically. That is, you can write a program or you can code where your layout, how your layouts should be. All right. The most common Android layouts include linear layout, frame layout, relative layout, and grid layout. We'll be explaining each in the coming slides. Now let's discuss about linear layouts in Android. Linear layout is a layout in view group which aligns all children either vertically or horizontally, which means that you can align your views in a single row or in a single column. Now this is how this picture shows you how it can be arranged. Now the first picture shows a column arrangement, and the second picture shows a row arrangement. Now the XML attributes supported in linear layout include Android orientation, which specifies if the layout should be a column or a row. We use horizontal for a row and vertical for a column, and the default case is always horizontal. Then we have the second attribute, Android gravity. Now this specifies how an object should position its content both on X and Y axis within its own bounds. Frame layouts in Android. Frame layouts are designed to block out an area on the screen to display it as a single item. Generally, a frame layout should be used to hold a single child view, since it is difficult to organize child views without overlapping. Okay, so how can we arrange the layout in such a way without overlapping so that we can see all the items in a single screen? Now this is an example showing a frame layout. This picture depicts that I can view the item 1 and item 2 in a single frame if I am using frame layout. Now the XML attributes which is supported in frame layout includes Android foreground gravity. Now this defines the gravity to apply to the foreground drawables. It can be either bottom center or center horizontal or center underscore vertical, where in which position I want to align the corresponding views, I can mention it in this way. It can be either at the right corner or a left corner or a center portion or a bottom right as shown in the figure. Relative layouts in Android. Relative layouts are view groups that display child views in relative position. It means it enables to specify how the child views can be positioned relative to each other. Now, the position of each view can be specified as relative to the sibling elements, like as to the left of or one below the other, or in positions which is relative to the parent's relative layout area, which means it can be aligned to the bottom left, or it can be aligned to the left, or it can be aligned to center. Now that is making use of a relative layout. You can align two elements, one below the other, centered in the screen, or you can make it centered left, and so on and so forth. Now, this is the picture which depicts how you can align your views relative to other views. You can position it relative to the other views. Now, some common XML attributes which is specific to relative layouts include Android ID, ID, and Android gravity. Now, Android ID helps to uniquely identify the layout. Now, the layout is identified using, if you are setting ID to some value, that particular layout is uniquely identified using Android ID. And Android gravity specifies how an object should position its content on both X and Y axis. Grid layouts in Android. Grid layouts are layouts that places its children in a rectangular grid. Now, a grid is actually composed of many thin lines that will be separating the area of your screen into cells. Normally, a grid with n columns will be having n plus 1 indices, grid indices that run from 0 till n inclusive. So this is how it looks like. See, as you can see here in the figure, the screen is divided into 1, 2, 3, 4, 5, 6, 7 and 8 grids, where you can view 6 grids. And the XML attributes, there are a lot of XML attributes that is possible in grid layout. I've listed 2 of them, where Android align mode, Android align mode, when it is set to align margin mode, it causes alignment to take place between the outer boundary of a view as defined by its margin. Then we have Android row count, which indicates maximum number of rows to create when automatically positioning the children. Similarly, you have column count as an attribute for grid layout also. That's it about today's lecture session. If you have any doubts, you can contact me or you can email me. Thank you.